Good morning, ladies and gentlemen. Welcome to the video version of the Week 22 regular sophomore SAT prep math lesson. For the third week in a row, we're talking about solving by factoring and equivalent expressions. Now, the add here is that we did not talk about solving last week. So we are taking up a half step in difficulty, but we've been talking about factoring and equivalent expressions for a number of weeks now. Once again, this video is being provided as a method for any student who is absent to get the coverage of the lesson so that they can complete the skill check, which is being included as part of their Algebra 1 grade. Or someone who needs just a refresher before they finish that lesson, that skill check online. So we're going to jump in here. Examples 1 and 2 are similar to the ones that we talked about last week. Expression 1, again, this is more about the wording on how things would be worded on the SAT and getting used to that than it is about the actual questions that will appear on the SAT, because we can't really predict that. What we can predict is the way things are worded and the overall approach they take to mathematics. So example 1 says, when the given expression below is rewritten in the form a times x plus b times x plus c, where a, b, and c are constants, and c is greater than b, what is the value of a plus b? So there's a little bit of a typo here. It should also say, a, b, and c. But anyway, we're being told that c is bigger than b, and we're being asked to factor this expression. Now, the fact that there's an a in front of those two sets of parentheses implies that there is a greatest common factor, and we should always be looking for a greatest common factor to factor out first. In this case, all three of these terms contain a factor of 2. So I can pull that factor out in front if I divide all three terms by 2. So that would give me 2 times the quantity x squared minus 6x minus 16. Now that remaining trinomial there, that can be factored. We're looking for a pair of numbers that multiplies to negative 16 and adds to negative 6, which we've been practicing for several weeks now. Those numbers would be negative 8 and 2. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. So that tells us that this expression factors into x minus 8 and x plus 2. From there, we can identify our three values. We have that a is 2, and then the other two numbers here, negative 8 and positive 2, well, we're told c is greater than b. So because 2 is greater than negative 8, that tells us that c is 2 and b is negative 8. Now, once we know that, we can then answer the actual question, which is something that's very common on the SAT. We have to do something, and then we can answer the question. So it says, what is the value of a plus b? So we would say, okay, well, a plus b, in this case, is 2 plus negative 8, which would be negative 6. So we should be answering A. Okay, so that takes care of our first question. Now we're moving on to example number 2. Similar question says when the given expression is rewritten in the form ax minus b times x minus c, where a, b, and c are constants, what is the value of a minus b plus c? So again, we need to figure out what a, b, and c are in order to solve this problem. So this is our advanced factoring, where we have a is not equal to 1. So at our school, we use Michigan M factoring, which looks something like this. We are supposed to be figuring out the two numbers that multiply to a times c, so 2 times 3 is 6. So looking for a pair of numbers that multiplies to 6 and adds to negative 5. Well, that would be negative 2 and negative 3, which means we bring that first term down, 2x squared. Then we split the negative 5x. That gets split up into negative 2x and negative 3x, because negative 2 and negative 3 are the numbers that multiply to 6 and add to negative 5. We also bring down the plus 3. The point of this is to turn our trinomial into a 4-term polynomial so that we can factor it by grouping. So we group the first 2 terms and we group the second 2 terms. Then we factor the GCF out of each group. So the first group, 2x squared minus 2x, has a GCF of 2x, which leaves x minus 1 on the inside. The second set of parentheses has a GCF of 3, but since we want the inside to be the same, we actually take out a negative 3, which leaves x minus 1. This creates a binomial with a common factor of x minus 1, which allows us to finish this factoring and say that this factors into what is in front of the parentheses, 2x minus 3, times what is inside the parentheses, x minus 1. And then if we examine the directions, we can see that we can now identify the values of a, b, and c. Okay, that tells us, because that's compared to what's in the directions, a is 2, b is 3, c is 1, as identified with the highlighters there. Okay, so that allows us to answer the question that is actually being asked. What is the value of a minus b plus c? So that would be 2 minus 3 plus 1, which would be 0. Okay, so that does it for our first 2 examples. Again, these are just more examples like the ones we've talked about in previous weeks. It's example 3 where we're going to start seeing new material. So in example 3, the wording is a little bit different, but the overall approach is going to be the same. It says the solutions to the equation shown are a and b, where a and b are constants and a is greater than b. What is the value of a plus b? So in this case, we're now solving an equation, which does make it a little bit different. First of all, one side must equal 0 to solve a quadratic. This is a quadratic equation. Anytime we see an x squared, we have to move everything to one side of the equation. Once we do that, which is already done here in this example, then we are simply factoring. We're looking for 2 numbers that multiply to negative 60 and add to negative 11. That would be negative 15 and positive 4. So this factors into x minus 15 and x plus 4. So that turns this equation into x minus 15 times x plus 4 equals 0. Then we have to understand that in order for these 2 binomials to multiply to 0, one of those 2 binomials has to equal 0. So we should then be breaking this up, at least mentally, into 2 separate equations, because either x minus 15 has to equal 0 or x plus 4 has to equal 0. And then we solve those equations to get the solutions to the quadratic equation. So our possible solutions are x equals 15 and x equals negative 4. So from there, we are told up in the directions that a is greater than b. So since a is greater than b and 15 is greater than negative 4, that allows us to state that a is 15 and b is negative 4. Which in turn, again, allows us to answer the question just like it did on the previous examples. The question is, what is the value of a plus b? Well, a plus b is 15 plus negative 4. That is 11. Example 4 is a half step up in difficulty because one side of the equation does not yet equal 0. One side of that equation has to equal 0 in order to solve a quadratic equation. Anytime we see x squared, we have to put everything on one side. And we should always try to move everything to the side where the x squared term would be positive. So we're going to move everything from the right side to the left side. We're going to subtract 2x squared we're going to add 3x, and we are going to subtract 20. Now the x squared and the x terms, those have like terms on the other side, so we're going to combine those. That would give us x squared plus 8x, and then that minus 20 is on the end, equals 0. We're then going to factor. So we're looking for two numbers that multiply to negative 20 and add to positive 8. That would be 10 and negative 2. So this factors into x plus 10 and x minus 2, which means that our answers are taking each of those factors and setting them equal to 0. So either x plus 10 equals 0 or x minus 2 equals 0. We would then solve each of those equations, which are one-step equations, and we would get our answers, which are x is negative 10, x equals positive 2. Now again, right here it says a is greater than b. Well, 2 is greater than negative 10. So that tells us that a is 2 and b is negative 10. Now that we know the values of a and b, we are able to answer the actual question, which was, what is 3a plus 2b? So that's 3 times 2 plus 2 times negative 10, or 6 minus 20, which would be negative 14. The answer is B. Okay, at this point, we should be going over to Google Classroom, where we will have a Quiz-Is assignment waiting for us. Now, if you did not do it the week that it was assigned, you may need to email me, Mr. Wills, to get a game code to complete your skill check. If it's only been a week, and it's just the week after this, there should be one up and running already for makeup along with this video. So, folks, again, the expectation is that you're taking your time and trying the best you can on the Quiz-Is skill check, which can be found on the Google Classroom. I'm going to put the code for the sophomore Google Classroom up here on the screen so that everybody has it. The Google Classroom code for the sophomore SAT Math Prep Plug Time is Q7ULRP5. So join that group, join that classroom if you have not done so already, and complete the skill checks. If you cannot access a skill check, you need to email Mr. Wills with the date of the skill check that you are trying to make up. Thank you very much for your time and attention. Good luck on the Quiz-Is skill check.